Okay, quick review that yesterday you built that, or most of you did, and learned that three-dimensional space is pretty important in organic chemistry, right? Like that now makes sense to you, but it didn't before you got your hands on the models. That in fact, that's like a table that doesn't like to be flat, but when you do flatten it out, that's when you realize that every carbon has an up and a down spot, and the stuff has to be plugged into the right ones to be the right molecules. Some of you got it right immediately. Some of you had to sort of learn that it does matter. You can't just bend it and make it point the other way. You're going to have to pull it off and switch it, right? So that was yesterday. We did talk about polysaccharides as well yesterday that are all made of glucose, but very different in how they bond to each other. And that was that. Let's talk proteins. Today's a day you want to really zoom in on because I've told you so far that I won't make you draw glucose from memory. That's true. Won't make you draw any of those polysaccharides either. This is the day when there's some stuff that I will expect you to know from memory. The components of proteins are simple enough that that's going to be the one that I expect you to have in your brain. Okay? Anybody know what proteins are made of? What are the single units that make up proteins? Say again? No, enzymes are a type of protein, for sure, one of the more important types. But the little pieces that make up the big chunks that are proteins. Anyone? All right. Because that's the thing you're going to need to learn how to draw. Amino acids. Probably sounds familiar. Amino acids. And the bonds in between them we call peptide bonds. So knowing your functional groups as well as you do, what two functional groups are we going to find on an amino acid? Well, you know one of them, right? What's the obvious one? The functional group that we know is going to be on an amino acid.
The amino group?
How about the amino group? Yeah? Yeah, and that's the one that's the nitrogen with the two hydrogens hanging off the carbon. Yeah, that's half the battle. What's the one, though? What's the functional group that makes any chain of carbons into an organic acid? Excellent. Carboxyl. If you know those two, if you know amino, and you know carboxyl groups, you can draw most of an amino acid. That's what it looks like. Draw it carefully, please. What you're getting right now is nitrogen, because you'll need it to build an amino acid, an amino group. Some of your nitrogens have 3 prongs, some have 4. I don't know why. Some have 4. Maybe there's some case where nitrogen can form 4 bonds. I have no idea. So what's here? This. Anybody know what element has the symbol R? Nope, that would be RA, I think, or maybe RN. None of them. That's why they chose it, so that you wouldn't mistake it for some other element. The R is a placeholder. This is basically a generalized amino acid structure where what's in that R spot determines which amino acid it is. It turns out there's 20 different amino acids. Each one has a different thing in that R spot, but other than that, they are all the same. They're all like this. So this part stays the same. This part changes. 20 different things can be in that R spot, from as simple as a single atom of hydrogen, that is the amino acid glycine, or a methyl group, right? CH4, that's the amino acid alanine. to as complicated as a ring of 6 carbons hanging off of there. Big honking thing hanging off there. That's phenylalanine. You won't have to memorize these, okay? Till you take maybe college biochemistry, and then I think you have to know. But other than that, just know the general structure. And anytime, but this is the thing I'll expect you to be able to draw. And if I expect you to put something specific in the R spot, I'll tell you. You know, I'll say glycine is the amino acid that has an H in its R spot. Draw me glycine. Make sense? Questions? You're not the only one that has them. Okay. Guess what we're going to do? The only way we know how to bond two things together, dehydration synthesis, that's how we make amino acids into dipeptides and then eventually protein. I'll make you draw the dipeptide. Okay, so we're about to draw 2 amino acids getting joined into a dipeptide. Be some drawing, so brace yourselves. Here we go. Wait for me to finish this top line, okay? We're going to take 2 of these things. And this one, let's label those functional groups. An amino group, and a carboxyl group. Wait, then we're going to put it next to another one. And then remember, it takes an OH from one and an H from the other. So that's how we're lining them up. Go ahead and draw that. Okay, everybody should also have 2 little flexible white bonds, ones that are a little longer than the gray ones. Anybody not get those from me as I was walking around? So now you have a nitrogen and 2 flexible white bonds, and that'll get us to that amino acid structure we need. Questions so far? You see what we're doing, right? You see where this is going? The next drawing we'll make is of what we call a dipeptide, and it'll have that OH and that H missing. And what 2 atoms is the bond between them going to be? Between which 2 atoms will the bond be that we just joined them with? Yeah. Not H. H can only make 1 bond. That H is gone. It's between the carbon and the nitrogen. C and N. Exactly. So here it is. That bond between the C and the N we call a dipeptide bond. And what other molecule are we going to get out of this? Because it's dehydration synthesis. We're going to get water. Water on the side. You still alive? So that's it. That's the thing that I'll ask you to draw. I'll ask you to draw either generalized or specific amino acids, always telling you what's in the R spot, if anything. And then I could ask you, actually really with any of these, I could ask you to draw them bonding together with dehydration synthesis. This is the one you'll have to draw from memory. We get to fatty acids tomorrow. I won't make you memorize those, but I would maybe give you a couple already drawn and say, okay, now draw them bonded with dehydration synthesis. We'll get to that. Could give you 2 glucoses and make you bond them. Although that's a lot of drawing. Maybe. Any questions? Yeah.
So like for the peptide, does that just mean because it has 2 R spots?
No, the R's are just, you know, if this is real, you know, maybe there's a hydrogen here and a methyl group here. You know, we're not saying what's here yet.
You want us to memorize the dipeptide, or then no?
All you have to memorize is a single amino acid.
Yeah.
If you know that, then you can make the dipeptide by bonding them together, right?
Whenever you use dehydration synthesis for the H2O,
Yeah, we won't always draw it, but whenever you do dehydration synthesis, a water comes out and exists. And if it's you, just kind of fades into the 70% water you already are. Yep. Okay, just a couple more things. Like I said, there are 20 different R groups, which means there's 20 different amino acids. Each one with a different thing in that R spot. But the thing about those R groups is each one, they're all part of a long chain. Each one does something different to the chain. Some make the chain bend a little bit. Some actually make it fold back on itself. Some of them make it acidic. Some make it basic. It's an amino acid, right? But if it has something real basic hanging off the side, it's going to turn that protein a little bit basic. Depending on what's there in what order, that's what makes proteins the way they are. So, like we said, bond two together, it's a dipeptide. More than two, it's a polypeptide. It doesn't count as a protein until it's gotten, longer than 100 usually, amino acids long. And all those different amino acids have caused it to bend and fold and take some kind of three-dimensional shape. That shape is what lets the protein do its job. So it's not a protein until it's folded. If it ever loses that folding, call it denaturing, then it doesn't work anymore. One of the reasons that heat is so bad for living things, why heat is generally worse than cold, is that heat denatures our proteins. All right, one last thing, which is that of the 4 big macromolecule types, 3 of them are polymers. And a polymer is just a big molecule that's made of lots of repeating little molecules. Proteins count, right? Proteins are big repeating molecules made of a lot of little amino acids. So it's worth getting some of that terminology down real quick. Monomers make up polymers. And the monomers we've talked about so far are monosaccharides, amino acids. And the one we haven't talked about is nucleotides. Not us. The polymers they make up, well, you know 2 of them already. Polysaccharides, like starches, cellulose, chitin. Proteins, big long chains of amino acids. And what you get when you string a bunch of nucleotides together, since nucleotides are the single units of nucleic acids, is you get DNA or RNA. All right. I have model worksheet number 2 for you. I promise it's not nearly as long as number 1. Doesn't even start to the backside. And I'm not going to expect you to finish the backside of yesterday's, right? Just the front side, at least so far. The backside is worth it. We'll do it. All right, got it. So you're going to be building amino acids once you're done with your carbohydrate stuff, and feel free to catch up on that. Get my signature if you need it. But building an amino acid just takes one little trick, and the trick is a double bond, right? That carboxyl group has a double bond. We haven't done that yet. Not hard. Miss anybody? All right. Check it out. I'm going to make a carboxyl group. Here's what I'm going to need. I'm going to need 2 of these white flexible bonds, which I've given each of you. The nitrogen you've got, that's how you're going to make the amino group. If you got a nitrogen with 4 prongs on it, just ignore one of them. Nitrogen only makes 3. So you've got your carbon, and you want to make your carboxyl group. What you're going to do is take those 2 white bonds and actually stick them both onto the carbon, and you're going to bend them. And then you'll take your oxygen, and you'll actually plug it into 1, bend it, plug it into 2. That's your double bonded oxygen. Everybody see that?
Mm-hmm.
So plug it into 1. Where's the camera? Bend it, plug it into 2. That's your double bonded oxygen. Then you just need the OH coming off the side, right? Because there's another OH in the carboxyl, so you put another oxygen on there, another hydrogen, and that is one end of your amino acid. Questions? Okay, get to work. Raise your hand if you need me to sign off on your glucose, and I will be around to help. Don't sweat like getting all of the amino acid worksheet done today. We don't have a ton of time. 34? Yeah. So yeah, we got a decent amount of time. 15 minutes. All right. I should press stop.